Hello friends, this video on Communication Systems Part 16 is brought to you by examfear.com. No more fear from exam. Now let us try to understand how the amplitude modulated wave is actually produced in real life. Till now we are only talking theoretically. First we talked about the graphical method, that how amplitude modulated wave is formed. Just now we talked about the mathematical method. Now let us see how experimentally or how in practical life an amplitude modulated wave can be produced. So let us see how is an amplitude modulation wave produced. So basically the device which actually produces this modulated wave is known as a modulator. So we are now studying the structure of a basic modulator. So what is the basic thing that we have? We have a modulating signal. So a modulating signal is like this: AM sine omega m t. Now when this modulating signal is added to a carrier wave, so a carrier wave looks like this: AC sine omega c t. So when this acts on a carrier wave, what happens? A modulating signal is formed, which is a combination of these two, that is AM sine omega mt combines with the carrier wave. Right? Now this output which is formed, I have already given the exact form of the output in the previous slide. Then what happens? This output is made to pass through a square law device. Now there is a new term. What is a square law device? A square law device is any device into which when you give an input x, the output y is of this form. And that is why it is known as a square law device. So here if you see, the output all depends not only on the input linearly but also on the square of the input, where b and c are constants. So this is how the output would be, right? And this is how amplitude modulated wave is produced, right? So now we will see that how the output is in this case. So here we have assumed that this x of t, that is input, is nothing but the combination, a simple combination of the modulating signal and the carrier wave. So let us try to determine the output in this case. So what would be the output in this case? Y of t will be equal to b into x of t, that is am sine omega m t plus ac sine omega c t plus c into x square, that is am sine omega m t plus ac sine omega c t whole square. So now let us solve this equation. So what do we get? We get it as BAM sine omega m t plus BAC sine omega c t plus c into, this is a plus b whole square, so we can write it as a square plus b square plus 2ab, that is 2amac sine omega mt sine omega c t. Right? So let me make a wall here. So let us continue with the calculation on this side. So this becomes equal to BAM sine omega m t plus BAC sine omega c t plus am square into c sine square omega m t plus ac square into c sine square omega c t plus 2c am ac sine omega m t sine omega c t. Right? Now again we will take help of trigonometric formulas. We know that sine square a is equal to 1 minus cos 2a divided by 2. And we also know the formula which we used in the previous slide, that is sine a sine b is equal to half cos a minus b minus cos a plus b. So we will make use of these two formulas. So where will we use them? So here you can see in sine square omega mt and sine square omega ct, we can make use of this formula sine square a. And for this part, that is sine omega mt sine omega ct, we can make use of sine a sine b. So now we will do the same. So using that, what do we get? We will get BAM sine omega mt plus BAC sine omega c t plus c into am square 1 minus cos 2 omega m t divided by 2 plus c into ac square 1 minus cos 2 omega c into t divided by 2 plus 2c am ac into 1 by 2 cos a minus b, that is cos omega mt minus omega c t minus cos omega mt plus omega c t. So this 2 and this 2 will get cancelled. So what will we get? We get y of t is equal to BAM sine omega m t plus BAC sine omega c t plus c into am square divided by 2 minus c into am square divided by 2 cos 2 omega m t plus c into ac square divided by 2 minus c into ac square divided by 2 cos 2 omega c into t plus c into amac cos omega m minus omega c into t minus c into amac cos omega m plus omega c into t. So it is nothing but the simple calculation, right? I just took everything out of the brackets and put them into the formula. So now let's see. So we get y of t is equal to BAM sine omega m t plus BAC sine omega c t plus c by 2 am square plus ac square. So if you see, I have combined these two terms together, right? And then we have minus c am square divided by 2 cos 2 omega m t minus c ac square divided by 2 cos 2 omega c into t plus c into amac. I have taken common in these two terms, this term and this term. I can take c amac as common. So this becomes cos omega m minus omega c into t minus cos omega m plus omega c into t. So if you look at this output, what do you see? What are the DC terms here? I mean, which are the terms which do not involve sine and cos? The only term that do not involve sine and cos is c by 2 am square plus ac square. So we can say that the DC term, that is the direct current, is c by 2 am square plus ac square. And I have already discussed about alternating currents in one of my previous lessons, right? So you know what is direct current, what is alternating current. So AC, DC, all those things are clear by now. So this is the only DC term in this output. Rest all are sinusoids, right? Rest are sinusoids. So whenever I talk of sinusoids, they have some frequencies, right? So what are those frequencies? Some of them have frequencies omega m, some have frequency omega c, some of them have a frequency of 2 omega m, some have 2 omega c, yet other have omega m minus omega c, and some have omega m plus omega c. So we see that when you look at the output, it has got sinusoids of many different types of frequencies. It has got sinusoids with frequencies same as carrier wave, some has same as the modulating signal, some of them double of them. So it has got a variety of sinusoid waves. So what do we do then? So once we get this output, what do we need? We want amplitude modulated wave. So we use a band pass filter. So that is the last step to produce amplitude modulated wave. So what will this band pass filter do? Filter generally, what does it do? It blocks certain signals. So this band pass filter will reject DC. So one term is gone. So this term is gone. It will not only reject DC, it will also reject the frequencies omega m, 2 omega m, 2 omega c. So now when all these terms are rejected by the filter, what is left with? So what is the leftover? The leftover is omega c plus omega m, and omega c minus omega m. And what are these? These are nothing but the frequencies of the amplitude modulated wave, which we discussed in our previous topic. We saw that the amplitude modulated wave will consist of these three frequencies. So what did you observe? So how is it actually produced? So the first step is the modulating signal. Modulating signal will combine with the carrier wave. So they will together form some signal, xt. This signal is made to pass through the square law device. This square law device will give output in the form of this y. So here you can see this output will have a lot of different ranges of frequencies. Then it will be made to pass through a band pass filter. So what will this filter do? It will block everything else other than the amplitude modulated wave. So it will block everything else. So it will keep only all that is needed for an amplitude modulated wave. So this is how an amplitude modulated wave is produced. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.